when I get disconnected. And here you can put the numbers, and here you use the energy stored in this spring, or you can also use the energy stored in the block, that is kinetic energy, half mv squared. But both have to give the same answer. You can double check because you know the Vm value, you know the mass, so you can. But here, one method would be sufficient. So the mechanical energy of the oscillator is given by. Someone is shouting. Second. Maybe I can. Okay. All right. All right. So here, this one. So this one was, I think, the last question that we had to discuss in this tutorial. So everyone is good, I think, right? And we can go to then tutorial 8. Had some problems, right? Tutorial 8. We can finish those things off, so we are done with that. Also, but the quiz, I think we can't have tomorrow because of I'm not sure what is the situation next week, but so any questions? No questions? I think these things are not very difficult. All right. Let me share the Tute 8. Yeah, I think you can see the screen. Tutorial 8, we went up to, I think tutorial 9 was due today, but I don't know how many people can submit it. But submit it as soon as you come to the faculty, because then I can do that tutorial class also. So probably that deadline also has to be extended to next Monday. All right. That we went through first problem, second problem. First problem, the physical pendulum and pendulum in the elevator and free fall, these things. And we can now go through problem number 3. It is also kind of a physical pendulum. Right? Remember we went through this one, I think, last time. Yes, this problem 2. And problem 3, we can go through, and you can read the question and remind yourself, right? The mark, the period of oscillation is given, fine. Yeah, I put a hint, maybe last time. Sure. Yeah, so this is so it is the period of oscillation is given. It is asking what is where actually the hole is located from the 50 centimeter mark, right? So this is also oscillation problem. So this is also physical pendulum. So we already know in the first part, I think problem number 1, you already derived the period uh, equation T equal to 5 square root I over mgh for a physical pendulum where I is the inertia at the pivot point. H is the distance to the center of mass from the uh, pivot point. That is the point of that is rotational axis, the point where the rotational axis is located. Right. And simply you have to just, since you have to use that formula, yeah, somehow I think it's the equation 29 in the notes, but it is also available in this tutorial itself. And you have put the numbers here, and basically you can find what D is. So, but here the inertia at this I is the inertia not at the center of mass, but at the rotational axis, the pivot point, uh, pivot axis. So you have to find that using the parallel axis theorem. That is the equation for that. And so it is the center of mass value plus the mh squared, which is again the distance from the center of mass. And you get this formula when you put that is you plug in for I by this one using this value, and you get this value. So we are actually looking for the simple D. Simple D. Mass is not given. So hopefully the mass cancels. Of course, the mass cancels. So mass is gone. And you get the period like this. And you can rearrange the equation and take the square of the both sides. And you get this equation. And if you rearrange it as like quadratic equation, like remember ax squared dx plus c equals 0, which is the quadratic equation. Maybe you have done it in math during O level, right? Even in O level, very basic equations. And yeah, you just have to use the solution for the quadratic equation and get this one. Right. You can look up the equation for the solution for, because you are looking for the value of D, but it has a D squared and a D, so it's a quadratic equation, and there's a standard solution. you use that standard solution, and you can solve, but you will get two values for the D. Anyone heard about quadratic equation? Your math lecturer may have done that, of course, right? If not, there is a problem. Even these things are done in O level. These things, I think, as I remember. That is the solution for quadratic equation and A level, so I think. Right. Remember the solution for the quadratic equation. You can find it out even from the internet. You just have to type it in. Solution of the quadratic equation. Or that is x squared x plus c. So the solution here, it is x for the x, it is minus b plus or minus square root b squared 4ac over 2a. So since plus or minus, you get two solutions, because when you use the plus value, you get one solution, minus value another solution. But of course, this value cannot be true because it is meter stick. The length from the center cannot be 1.5 centimeters, right? It has to be the smaller value, because the maximum value you can have is 0.5 from the center. So this 1.5 is not correct answer. The other answer is the correct one, the minus value from here. So it is this much meters, 5.6 meters. The 0.056 meters. Any questions there? So these are like simple problems, but without knowing the method to solve that is basic problems, you will be unable to solve more complicated problems. So these are your engineering basics. And if no questions, I will go to the next one. You can type it in if you have some question. You can type it in the chat box, so you can speak. Better to type it in, because sometimes you get disturbed. And problem number 4 of tutorial 8, part 1. It says write a general expression for the displacement xt in a damped spring block oscillator with a damping constant B. So the damping constant is B. Remember, we did damped harmonic oscillations. So this is it is related to those lectures. So if you look up the lecture notes, you will notice that this is the solution for the displacement of the damped harmonic oscillator. Undamped, that is the normal harmonic oscillator, that this term is there, exponential indicator, right? And here the omega prime is given by this. That is the solution for the damped harmonic oscillator, where B is the damping constant. XM, it is the amplitude, and omega prime is again the that is angular frequency of the oscillation, right? Phi is the phase constant, and so on. And part two, so that is just something you have to answer by memory. Yeah, these things, so kind of from memory. And part two, it says also you can derive this equation, but I didn't give that question because it will be a bit more difficult, but you can look it up in the lecture notes, on the lecture notes, right? How to derive this for the damped harmonic oscillator. Remember the damped harmonic oscillator. There's a spring, the block, and additionally there is a vein that is immersed in a cup of water, which causes the damp when this oscillates up and down. And the second part, it says, for the damped harmonic oscillator system shown in the figure to the right, yeah, that is the same figure, or figure above, actually, yeah, with the figure to the right. And the mass is given, the K is given, the spin constant. And additionally, since it's a damped oscillator, the damping constant is given, B equal 70 grams per second. It is asking what is the ratio of the oscillation amplitude at the end of the 20 cycles to the initial oscillation amplitude. Because of the damping. So it is asking the ratio of the initial amplitude to the amplitude after after 20 cycles to the initial, right? So you just have to find this value. That is because that is the ratio, right? This is the ratio, the decay ratio. So at t equals 0, you see that e to the 0 is 1. So after 20 cycles, it will be less. So it is basically asking for this value. So you have to just find that value. But to find that value, you need the time in seconds, right? So to find the time in with 20 cycles, it is 20 periods, the time. 20 cycles times, but one period is, 2.5 square root m over k. So we can use this as the period because even though it is a damped oscillator, that the b is much less than square root of k. If that is the case, you can write the period same equation as the undamped oscillator. Doesn't mean that it is undamped, but the angular frequency and the period would be the same if the damping constant is quite small compared to this square root of km. So we can find the square root of km. If you find the square root of km, you see that square root of km is this much in grams per second, because the k value and m value is given, but the b is 70. So compared to this value, the damping constant is very small. So we can use the undamped period and you put the numbers, and you can find what is the time for 20 oscillations of the damped oscillator using the undamped period. And because it is asking after 20 cycles, so it is 20t. T is the period given by this. And you put the numbers here because you know the time, the damping constant, the mass in grams. So here we can use in grams because both are in grams, so the gram cancels, and you get the amplitude after 20 cycles will be about 0.4 of the initial amplitude. So as you can see, the amplitude of 0.39, so the amplitude decreases. So as the time increases, amplitude decreases. So this is the ratio that the question asked. Any questions there? Yeah, this is the continuation of that simple harmonic motion spring block oscillator, the damped version. Damping means that is it experiences some kind of drag force or uh, frictional force. Because of that, the amplitude decreases. So if there are no problems, I will go to the next problem. So that is also that is a easy problem related to this forced oscillations. Forced oscillation, you can read the problem and remind you. So if you have any slightest problem, you can ask me. Right? So these are fundamental stuff that you have to know in order to become a technologist in engineering technology, especially on the mechanical part. Mechanical. Also, there's electrical oscillators like that we'll maybe do in the next semester. Uh, they also have them, like they are made of like capacitors, inductors, resistors. So the resistor is the one actually causes the damping in electrical oscillator. But in a mechanical, we have the spring, the block, and yeah, the liquid which causes the damping. But they are very analogous. If you later maybe you will see during the next semester that they are very they have analogous explanations, and you can read the problem fine. Yeah, for the same kind of this figure, the same kind of figure, the rigid support is oscillated by an external oscillating force of angular frequency omega d at time t for the displacement of the wave xt xm cos omega dt plus 1. Yeah. So this is yeah, the equation for forced oscillator. That is oscillated using an external force, external oscillating force, maybe some kind of a vibrator, mechanical vibrator. So the omega d is the frequency of that vibrator. So the displacement can be written for such forced oscillator as such. But as you can see, the frequency of such oscillator is the driving frequency of the external oscillator. Suppose yeah, the amplitude may be a complex function like this. So in this case, this is the function. where Fm is the constant amplitude of the external oscillating force and omega is the natural angular oscillation frequency of the system. At resonance, what are the amplitude and velocity, amplitude of the oscillating object? It is asking. Okay. So the amplitude at resonance. So now I think you can remember at resonance, the driving frequency is equal to the natural frequency, uh, where omega is the natural frequency. So you just put omega d equal omega, so this term disappears, and you are left with only Fm b squared omega d squared square root. So you get actually Fm b omega, because you take the square root of the square, right? And part B, the velocity, amplitude of the oscillating object. That one also you can simply use the formula, and but you know what is the amplitude, and omega cancels and get the velocity amplitude by this formula. So this is the forced oscillations. So one might ask, then can I mix the forced and damped? Yeah, that is also possible. Forced oscillation, damped oscillation, right? Any questions? No? Right. So as I mentioned that you have to rename yourself by using your index number, at least the last part of that. That is the number. Right. Then only we can use it for attendance purposes. All right. So we are done. If you don't have any questions, we can go to the next tutorial. One student was asking about tutorial number 5. Perhaps we can go through that. Right. You are the student asked. Yeah. Last 3 questions of tutorial 5. Yeah, this is also related to one student asked how come velocity equals. I think here you are asking about this, right? So this is a standard equation. You can look it up. Same equation. Right. Yeah, you can prove it also if you like. You just take the derivative of this, and some of this is here, the standard equation for the velocity. One student is asking, do we have week 14, 15? Oh, yes. I mean, lectures currently, yeah, I have done most of the stuff that is, because now 8 tutorials I have done, and that is the lectures for that. So that would be much helpful for your in-semester, that is sitting for the in-semester exam, writing for that. So I would suggest you, as I often tell, do some past papers and also the discussion lectures and those things, and remind the midterm questions also. You can, well, the same questions are on the discussion, tutorial discussion lecture notes. Right. So try to guess what will come this time. So it is, yeah, the end semester I pretty much up to now, I kind of, yeah, the same kind of concepts were tested. Right? This time also, I think that would be the case. Whatever was taught can be tested, right? During the exam, that is the final exam. 60% of your marks are coming from the final exam. I think you already know. So usually a grade is made by the final exam. That is A, B, C, D, or whatever, like A plus or whatever, B plus, B minus, because 60% of the marks. But in order to pass, that is the pass the course, you have to pass the continuous assessment. That is, you have to get at least 50% out of 100. That is 50% for the continuous assessment. Else, right? For what one student is asking about rotational motion and circular motion, both. Yeah, you will have both. Both. That is, you have to have the knowledge of both. But yeah, of course, I'm not going to ask everything that I taught. But yeah, definitely for those two things, you have to know both. Because for circular motion, you basically have to know the center. For rotational motion, those that kinematic equations for the rotational motion, and also the other dynamic equations that the Newton's laws, how to apply that for the pulley, those things you have to. So it's pretty much everything that I covered or uncovered for you, right? That number 5. The exam. The faculty
Recording in
assumes that you are
progress.
not planning to sit. Yeah, this course, there are some that is repeat students also, but hopefully all of you will pass. Um, and don't have to repeat. So that is up to you to decide. Are you going to pass it or planning to do it for next several years? Yes, some students pass the first time, which is the best time. Because when someone get repeat, the maximum they can get is a C. But the first time you can get up to a plus. So plan for a plus. All right. And let's go to tutorial 5. Um, So all tools are available, as I told. So it is up to you to decide, are you going to get a plus or what? So if you plan for A plus, at least you will get a B plus. I don't know. Some of you might get A plus itself. But if you plan for like a B or something, study, okay, still B is enough. Then sometimes things might be not that good. So plan for a A plus when you learn by yourself or group, but you have to practice by yourself, right? All right. And tutorial number 5, I think that's the one that student was referring to. Last 3 questions. Yeah, that also I was thinking a little. Yeah, these kind of questions are also in semester exams. If you check, uh, yeah, usually it is one question. This so each tutorial may contribute to one or two questions, that similar questions in the one or two or three from each tutorial, right? Yeah, this one. So tutorial maybe he was referring to which questions? Last 3 questions. That is the spring questions you are interested in, right? Yeah, the last 3 questions contain the spring. So this tutorial 5, I think you have to definitely study for the quiz 3 also, which is now currently postponed, probably to next week. Yes, it would have been tomorrow. And yeah, let's go through problem 6 first. Can you read the question? This is here the question from tutorial 5. Quiz 3. Uh, can you read the question and remind yourself? If you have a piece of paper, just you draw some sketch and you can open your tutorials also if you have it with you. Right. Tutorial 5, question number 6. So we did this tutorial class before, but this is kind of a revision. So the mass is given 12 kilograms block, which is released from rest on an incline of angle theta equal 30 degrees. Theta is 30 degrees, and there is some frictional the friction between the block and the inclined surface. That kinetic friction is 0.20 nu K is 0.20, right? And question asking how far does the block move down the incline from the rest position. So how do you solve that problem? Uh, that is part A. So here you have to immediately notice that you can use the conservation of energy in solving this problem. If you consider the spring block and the incline, that is block spring earth system is isolated, it is isolated. If you neglect any air drag, air resistance, then it would be isolated. And you can apply the conservation of energy to find how far the block will move uh, down the incline from the rest position. Uh, Practice. So in academia, most of that is a significant amount is done on paper using a pen. So that is the skill you obtain to solve problems using uh, pen and paper. And also there's a secondary part, which is the laboratory part, which you that is do it in the lab and get hands-on experience. So those are two kinds of skills, right? But this kind of skill, you have to do it by yourself. As I often tell, don't assume that without practice you can uh, solve problems, right? You should, to solve problems, you have to have practice. That is practice of solving problems and how to think in solving a problem. What are the logical steps, those things. Of course, I can, usually in exams, I can give a totally new problem. There are no restrictions. But usually, yeah, I have to not do that because there is the same concept, same principles, but a totally new kind of problem. Uh, but if you can't solve a problem that you already solved, how can you solve a problem that is a new problem, right? So these problems you can practice, practice, practice. So here the first thing I basically did is found the spring constant, but it's not necessary to find it first. You can do it later also using the Hooke's law, because the problem says the spring is compressed by 2 centimeter by a force of 270 newtons. And you can use that in the Hooke's law and find the spring constant. But the main part of the problem is applying the conservation of energy with thermal dissipation. We only take, there are no any other internal energies other than thermal dissipation. So that's why I just wrote it like that. But you can just write applying conservation of energy to the block spring system, isolated system. So the important thing to apply conservation of energy in this problem, this example is isolated. The system has to be isolated, isolated. That is separated from other things, right? So if you take the spring block and the earth, then that would be isolated. And you can apply the conservation of energy. Or here I'm only taking the thermal energy. So to you that mechanical energy equation, only difference is that on the left side there would be a thermal part, that is plus delta TH. And so this thing you have to remember. The other thing here is that here there are two potential energies. That is U. All kinetic energies are the same, right? There is no kinetic, but potential energy, different kinds of potential energy. Here you have gravitational potential and the spring potential. So it is plus sum of those two. So instead of U, I can write like this, and basically you get a bit long equation. That is the potential term splits into two, the gravitational part and the spring or the elastic potential. Any questions there? So this one has to be crystal clear to you. So it's the fundamental uh, law of nature, conservation of energy. But here we are only taking the mechanical and thermal energy, no any electrical or uh, chemical or biological energies. But of course, if they are there, you can put that things also into the equation, right? And as usual, you have to clearly define where you choose your gravitational reference, the gravitational potential reference level. So the reference level is relevant only for the gravitation potential, not for the spring potential, because the spring potential always we take the reference level at the relaxed position of the spring, right? So here I marked my reference, my choice at the initial release level of the block. So usually in the spring block problems, I choose the initial release level of the block as my reference level because that makes sense in most of the problems. Spring block incline problems, so spring block problems. Right? But for pendulum problems, I choose the suspension level as my reference level, but it is you can choose your own level. Final answer should not depend on your choice of reference of the gravitational potential reference. That is the zero gravitational potential level. And so if the blocks goes down here, I just take the front surface of, because that is the one hitting the spring. Yeah, usually in these problems, I take the front surface and how far it moves. So when the block here start from rest and after spring get compressed, it comes to rest again. So what would be the initial and final kinetic energy? Anyone? Start from rest, end from rest. So what is the initial and final kinetic energy?
0.
Anyone? So 0, yes. So good. So I just put here like this here, but you don't have to write everything. I just put everything, but you have to clearly indicate where you choose at least the gravitation. So you in the equation now you see the final kf is the final kinetic energy, which is 0. Ki is the initial kinetic energy, which is also 0. Yeah. Yeah, these things you have to don't, as I told you, don't have to write everything like this. But these things you have to write, these equations, this part. And also you have to clearly indicate where you choose the gravitation, either in the text, like this UG bindu, that is 0, at the position where the block was initially released. Because if you just don't write it or mark it, no one knows where you choose the gravitational potential level. So your solution has no sense. For the gravitational potential, that's why you have to clearly indicate where you choose the reference level. And the other energies are the gravitational potential final. So like if you choose like this here, the reference level, u equals 0, y equals 0 at the initial height of the initial release point of the block, and I take the front surface. Here one might take the center of mass if they like, but for simplicity, I will take the front surface of the block. That doesn't matter much. It's just, yeah, you can treat the block as a point particle also, right? So that's what. And I mark just here. So this would be the initial gravitational. This would be the final for both spring and the this point here. So this front surface will come and stop here at the point F, right? That's the idea. Since I am using the same figure again and again, I don't know to grow the block. I am just reusing the same background figure, right? So, but if you like, you can draw the block come the line like that. And yeah. But the spring initial point is here, this one, right? So the initial point for the block and the spring are different. So I put GI here, SI here. So this, let's say the spring compresses by a distance D, and the block moves by a, so that is distance capital D before stopping. Then I can fill these equations. But here the YF, the final gravitational, you see that in this, because mgy is the gravitational potential, but the y is negative. Y is negative d sine theta. Right? Any questions there? No? So just because remember the gravitational potential, we did this from the beginning of the lectures for potential energy. The gravitational potential energy is given by mg y, where y is the distance from the or position from the, that is the distance from the reference level. And here, since it is below the reference level, it's negative d sine t. And since I assume the spring compressed by a distance d, I can write this is half kd squared, right? Because remember the spring potential is given by half kx squared, right? So those things you have to remember, like what is the potential energy due to a spring or elastic potential energy, right? It is half kx squared, right? And but the x here is d, here the compressed distance I take d, so the x become d or minus d, but doesn't matter because d squared it is. So half kd squared. And the thermal energy, I will leave it as it is. And in the next step, we will find the thermal energy. Yeah, so here basically you see that the total energy is 0, while here, initial and final, the total energy is 0, but in the final state, some of the energy became negative, and yeah, because of that, other energies increased as positive energies, right? So you get this equation. Yeah, maybe you can skip some of the lines here. I am just putting all the lines because some people might not understand. But you can skip some of the lines if you understand. You don't have to even write the MGY. You can directly write this. If you understand that, you write this and this and this. And here, to find the thermal energy, you know that the thermal energy is given by the kinetic friction times frictional force times the displacement. So that thing also you have to clearly remember how to find the thermal energy, which is given FKD. But the FK is what? Mu K, Fn, where mu K is the coefficient of kinetic friction, Fn is the normal force, D is the displacement, that is this displacement. And you can put the numbers here. that is the values, because you know the normal force here, if you, yeah, like maybe draw the forces, the normal force is mg cosine theta in this case. That one maybe you can draw at the center of the block. Because the downward force would be mg, and if this angle is theta, here angle also theta, so the normal force become mg cosine theta. So instead of Fn, you put mg cosine theta, and you get this equation for the thermal energy, and you replace delta Th by that, and you get that equation. And since it is asking for the distance, I just rearrange the equation, and I can have this equation, and you put the numbers here. Yeah, one could put the numbers and already solve, but I would suggest you, because usually in exam questions, and I just want this part, not the numbers usually. Yeah, because one student might just put the numbers itself as he solves it. But first here I do is first solve for the what is asked and put the numbers. And you put the numbers and you find the distance as such. So I think this is a very straightforward problem, right? Not very. Now you have done it at least. I have done it for you at least maybe 3 times. So as I told, this is not what I do really matter. What matters in learning, because you are the one who's learning. So what matters is what you do. So I suggest you don't look at the answers and try to solve the problem again and again and compare the answer to see if it is correct. Right? Because this is a skill that you have to obtain, that is, you have to gain in order to become engineering graduate or engineering technology graduate. Right? Because graduates, they most of the time do work on paper. Yes, some become engineers, some become teachers, some become lecturers, some other professions, technologists maybe. Right? In any case, that graduates usually they have to use pen and paper, and also of course they do the practical parts also. Right? And part B, it is asking what is the speed when the block hits the spring. So these things, as I told, the listening will not completely, that is, make you learn. It is, you have to practice by yourself. All right. But if you don't listen, maybe it will be difficult for you to practice. That's why I'm doing it several times. Right. And that part also, but in that part, it is only this distance you have to find the x, capital X. It is asking what is the speed when the block hits, just before it hits the spring, just before it touches the spring. Then you can use the same. So in the previous one, the K value, here you found the K value previously, but you can find that K here also during this, after doing this part. This also similar, so part B also similar. It is asking for the speed instead of the distance, but the distance x you can calculate, because you know now you found the total distance it traveled, and the you know the amount that the spring got compressed. So you can just find what x is. This capital D minus simple d. Yeah, ultimately the x you can find. So yeah, the order doesn't matter. You can do it here or you can do it in the beginning of that part. And but ultimately in this part also you have to apply the conservation of energy. But I will reuse the previous equation. I just named it as equation A. And here, but the final kinetic energy is not zero. That is what we will use to find the speed. So that one doesn't become zero. And the distance traveled is x. So the height here, yf, is minus x sine theta. So this becomes this. It is kind of similar to part A, except for this part. We are looking for that. And here you get the similar equation for the thermal component. Instead of capital D, you have the capital X. Get that equation and you can find what is the V squared, and that's the final speed. And as this. And the X value you can put what it is, theta known. So you can, for other values you know, G you can put 9.82 or 9.81. In this tutorials we use 9.81 meters per square second, and just can find what is the speed. So for examinations and everything, you need practice. Don't assume that just listening to something will make you ready for the exams or any other like bigger things, right? Oops. Right. Any questions there? This is very straightforward thing, right? I just revised tutorial number 5, question number 6. Also, the question number 5 also a bit similar problem, but here the spring is attached to the block. Box in this case, bread box. And you can go through that also. It is similar concept, similar, but your question is a bit different, but the concepts are similar. The laws, we use again the conservation of energy, right? Here also the potential splits into two, the gravitational potential and the spring potential. I think everyone understands it, right? So these are the very fundamental concepts, very important. So if someone claims that they don't know these things, but they are the masterminds of the engineering or technology, especially mechanical, that would be nonsense. Right? And problem number 4 is the horizontal version of that. Horizontal, so the only difference is when answering most of the parts, you don't have to split the potential into gravitational and the spring potential, because here you can ignore the gravitational potential. Only the spring potential is the potential part, and the kinetics, and you put these things and find the speeds. This problem also solved a similar problem. You can ignore the gravitational potential because it is in the horizontal plane. The block moves, right? But in these problems, you have to consider the gravitational because uh, they are uh, moving on an incline, right? So there's effect from the gravitational potential, but here there's no effect on the energy. That the energy doesn't change because the level is the same, right? But in these problems, the level changes, the level of the block, thus changing the this gravitational potential. Okay, I think I will stop for now.
Recording stopped.
So do you have any questions? Now I think you have all the stuff. It's up to you to learn or not to learn. I cannot force. But I suggest you learn and someday maybe contribute to the economy and make your own company probably. And the real ones, I mean, not the fake ones. All right. Here, Sri Lanka, many people just bring parts and assemble here. That is also still you need the knowledge, right? Now they are making electric three-wheelers and the kits and those things in our faculty also. We are doing such stuff. Uh, so you have to have the mechanical and electrical knowledge. Um, yeah, one might ask, okay, like, why should I learn all these things? Why can't I just go and uh, do it immediately, right? But that is not the engineering academic way. That is the Basunya. Basunya learns by doing something in the garage, right? So if you want to someone thinking to become Basunya, then you don't need a degree. That is the problem. What I am trying to explain to many people. But right, then you just have to go to a garage and yeah, do that. But maybe that's not definitely not the idea of a degree holder, right? Uh, they have highly delicate, highly specialized knowledges, degree holders, even when you go further into higher studies. That is like the special task force of the that is president or something like that. So it is a different thing, right? Okay, so I will stop for now. Maybe we will do it tomorrow online. Yeah, we will try to do it tomorrow online. I will send the link. All right. So as I told, this is now your game. You are the players. You have to practice, right? You want to win a cricket match, you have to practice, right? Like that. Okay, so I'll stop now. All right. So good luck and good luck with your exams. All right. So be prepared for everything.